Hello friends. In the previous lecture we have discussed some terminology related to the SCADA. Now we will discuss in detail what are the field instrumentation. Field instrumentation fields refer to the devices that are connected to the equipment or the machine being controlled and monitored by the SCADA system. There are sensors for monitoring certain parameters and actuators for controlling certain modules of the system. So basically field instrumentation consists of input devices and output devices. The input devices are used that may be your sensors, that may be a temperature sensor, pressure sensor, limit switch. Okay, and these are used for sensing the certain parameters of the systems and monitor the certain parameters. Second thing is your output devices. These are basically actuators. These are used for controlling certain modules of the system. These instruments convert physical parameter, that is fluid flow, velocity, fluid level, etc. to the electrical signals, that is voltage or current, readable by the remote station equipments. Output can either be analog, continuous range, or a digital, discrete value. Some of the industry standard analog output of these sensors are 0 to 5 volt, 0 to 10 volt, 4 to 20 milliampere, and 0 to 20 milliampere. Voltage outputs are used when the sensors are installed near the controller, that is RTU or PLC. The current output are used when the sensors are located far from the controller. So basically these field instruments will convert physical parameters. Okay, that may be fluid power, that may be velocity, that may be temperature. Okay, into electrical signals. Now what are the electrical signals? Voltage and current. So a sensor will convert these physical parameters or certain value in terms of voltage and currents, and these voltage and current signals are readable by the remote station equipment. The output may be analog, that is continuous output, or discrete, that is digital output. Say what are the examples of continuous output? Temperature is an example of continuous output. So my temperature does not changes from 0 to 30 or 0 to 70 suddenly, so it requires certain times, it will increases gradually. Okay, in the same manner it will decreases also gradually. Velocity also does not changes from 0 to 300 rpm or 0 to 500 rpm or 0 to 1000 rpm. It will gradually increase 0, 10, 15 like that one. So these are called as the continuous range signals and commonly known as the analog signal. So these analog signals can be converted into 0 to 10 volt, 0 to 5 volt, 0 to 4 to 20 milliampere, or 0 to 20 milliampere signal. Again, there are next type of signal is called as a digital signal. It has only two values, either 0 or 1. Okay, means voltage is available or voltage is not available. So in that case, this it has only digital have only two values, either 0 or 1. But continuous signal or analog signal has a continuous range of values, and these are going to be changed over the period of time. Now some of the industry standard analog output of this sensor. So for analog signal, for digital we have only two definite value, that is 0 and 1. But for analog we are going to measure the analog signal in terms of voltage as well as current. So if you are going to measure the analog signal in terms of voltage, its value may be 0 to 5 volt, or it may be 0 to 10 volt, or it may be 4 to 20 milliampere, or it may be 0 to 20 milliampere. Now say I want to measure the 100 degree centigrade. Okay, 0 to 100 degree centigrade. So my temperature sensor will give me the output in terms of 0 to 20 milliampere. So for 100 degree centigrade it is 20 milliampere, and for a 0 degree centigrade its value is 0. So in between these, what are the values? So 100 by 20 means 5. For each 5 degree centigrade it will show you one value over here. So 1 means your 5 degree centigrade, 10 means your like that one, it is going to be changed over there. Okay, so the voltage outputs are used when the sensors are installed near the controller. Now when you have to use the voltage output and when you have to use the current output, so you are going to prefer the voltage output when sensors are located near the controllers or PLC or RTU, and when the sensors are located far away, there is a large distance between my controller and the equipment or sensor, then I have to go for the current output signals over there. Then digital outputs are used to differentiate the discrete status of equipment, usually one. One is used to means equipment is on and 0 means equipment is off. This also means 1 means full and 0 means empty. 1 means high and 0 means low. The actuators are used to turn on or turn off certain equipments like digital. Analog inputs are used for control. For example, digital inputs can be used to turn on and off the modules on equipment, while the analog inputs are used to control the speed of motor or position of the motorized valve. So when you have to select the digital and when you have to select the analog instrument, so when you if you want to just turn on and off the device, then you have to go for digital. But if you want to just gradually on or gradually off the device, change the speed and all these things, so at that time you have to go for the analog signal. Next is remote station. So field instruments connected to the plant or equipments being monitored are control are interfaced to the remote station to allow the process manipulation at remote site. It is also used to gather the data from equipment and transfer them to the central SCADA system. The remote station may either be RTU remote terminal unit or it is a PLC programmable logic controller. It may also be a single board or modular unit. So basically what is the remote station? Near the field or near your equipments. Okay, the field instruments are connected to the plant or equipment being monitored and controlled by control are interfaced to the remote station. So basically near the equipment to which you are connected the various sensors which are going to be monitored and controlled, that is done through the device or the through a station which is located near the field on the field, that is called as the remote station, and it allows the process manipulation at remote site. So what happened, the operator can change certain parameters over there and he can change the process, or he can just make certain changes into the process. This remote RTU also used to gather the data from equipment and transfer to the central SCADA. The one function of RTU is what? It will gather the information from the various sensor which is placed on the equipment and from the transducer and send it to the SCADA system. This is the example of your SCADA system. The remote station may be either RTU, the remote station may be your remote terminal unit, or it may be a PLC. Okay, so what you are going to observe over it, it is an example of SCADA system. So this is the SCADA system of your railway monitoring system or on the station. Okay, there are so many railway tracks and a person is continuously monitoring, and these are your tracks. These tracks are automatically going to be changed over here depending on the on which platform you want to just allow the train to come. Okay, so this is going to a person can easily monitor everything on this server, and if he want he can make the changes from this by initiating the command. He will make some manual changes, otherwise the changes are going to be automatically done depending on the sensors which are placed at the different location. Say here one sensor is there, that sensor will detect that the train is coming. Okay, so it will automatically switch on the signals, or he will automatically switch on the red signal, green signal, or uh, orange signal over there. He will automatically shut down the gate. This is thing going to be happen automatically. If it is not going to be happen automatically, then in case of emergency the operator can perform those actions from this location. Okay, so this is the central control system over here. Now what is RTU and what is PLC? RTU stands for remote terminal unit. It is a rugged computer with good radio interfacing. It is used in the situation where communications are more difficult. One advantage of RTU is its poor programmability. However, modern RTU are now offering good programmability compared to the PLC. So basically, remote terminal units is similar to the computer. Okay, but it has the good radio interfacing. Means what happened, the effect of noise on this signal system is somewhat less. It is your situation where communication is more difficult. So you are going to prefer the RTUs where communication is somewhat difficult over there. And one of the disadvantages, we cannot easily program this RTU. But now with the modern technological investment, it will offer the good programming comparable to the PLC. The PLC, what is PLC? Programmable Logic Controller is a small industrial computer usually found in factories. Its main use is to replace the relay logic of a plant or process. Today, the PLC is being used in SCADA system to due to its very good programmability. Nowadays, we are going to use the PLC system. Okay, PLC based system because what happened, it will provide you the good programmability. You can easily program, and the language used for PLC program is ladder logic, which is easily and it is very easy for to understand for the technical person. Earlier, PLC have no serial communication port for interfacing to radio for transferring of the data. Nowadays, PLC have extensive communication features and a wide support of popular radio units being used for the SCADA system. Okay, so nowadays, in the earlier days, PLC does not have serial port for communication, but now the PLC has serial port for communication. Also, they have USB port, and number of other things are going to be incorporated in the PLC. So you can easily connect the PLC to the SCADA system. In the near future, we are seeing the merging of RTU and PLC. So over the period of time, what happen in the future, the PLC and RTU becomes the same thing. PLC and RTU become one. Micrologic is offering the inexpensive RTU for SCADA system, wherein the PLC may be overskill solution. Okay, so basically now a Micrologic is offering extensive RTU solutions. Allen Bradley product is that. Okay, but over the period of time, the PLC will just give a better solution for this one. It is the microcontroller based RTU and can be interfaced to the radio modem for transmitting the data to the central management monitoring system. Now, the RTU are of two types, single board as well as modular unit. The remote station is usually available in two types, namely the single board and modular unit. The single board provides fixed number of input-output interface. Okay, in case of single board, what happened? We have the fixed number of input-output devices. We cannot increase the number of IO devices. But in case of the modular one, we can increase the number. Okay, do whatever the required to this one. We can increase the memory, we can increase the number of IO input switch input modules, then we can increase the number of output modules. Okay, but what happened, the cost of modular unit is some more than the single board unit. Okay, usually black pen is used to connect the modules. So basically what happened, that in the previous lecture we have discussed the modular PLC and single means your fixed PLC. So same thing is going to be happen over here. In case of modular unit, you can connect the number of modular units or number of IO units or memory units as per your requirement. So there is a backend in which you need to simply plug and play type switches are there. Now, what is the communication network that we are going to discuss in the next lecture?